Students, coming to the basics of the microprocessor continuation. In this case, we are going to see common terms used in microprocessor. So, after reviewing all these common terms, you can easily understand the microprocessor concept. Initially, we are going to see register. So, later we will see bus, instruction, program, word length, memory, clock, read, write, multiplex. So, initially, let us start with register. What is meant by register? Here, register is a group of flip-flops. Or collection of flip-flops. Register is a group of flip-flops or a collection of flip-flops. So you see here, the register is a type of computer memory. It is used to accept, store, transfer data and different instructions that being used immediately by the central processing unit CPU. There are many registers that are used in to perform different operations. The classifications of registers are general purpose register and special purpose registers. So before going to understanding this general purpose and special purpose registers, let us see general representation of the register. Register can be represented in the format of, that means register can be always represented rectangular boxes like this. Any rectangular box which represents in a register. Suppose if we want to store some fixed amount of binary information, with the help of register only we are going to access. That means we can access either read information or write information. This is the register. Inside, just observe here 8 boxes are there. For example, if the size is equal to 8, this complete rectangular box can be divided into 8 blocks. Each block which stores binary information, either logic 0 or logic 1. Same as it is previous. This block which stores either logic 0 or logic 1 like this. That means if the size is equal to 8 binary values we are going to store inside the register. How we are going to store these binary values? Inside, what is the physical element we are going to identify? That means inside flip-flop is there. Every block inside one flip-flop is there. This is a flip-flop, 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 flip-flop. So that means if it is 8, the register size is 8, we are going to expecting 8 flip-flops are there inside. If it is a 16-bit, we are going to expect, that means 16 flip-flops like this. If it is size equal to 16-bit, so that we are going to expect remaining 8 flip-flops are like this. So every flip-flop which is used to store binary values, that means how much capacity is always which stores, that means flip-flop is a memory cell. Generally, it is a memory cell. So what is memory? Storage space. How much memory it can store? Only one binary bit. Memory cell is which is used to store binary. How much memory we are going to store inside the flip-flop? That means either logic 0 or logic 1. So with the help of this flip-flop, we are going to store either logic 1 or logic 0. Coming to the classifications of the registers, general purpose register, special purpose register. Let us see, that means general purpose register. General purpose registers represent always our alphabets, that means A, B, C, D like this. That means A means accumulator, B means base, C means count, D means date. So all registers which indicates all are 8-bit registers. 8-bit register. So if you want to consider these general purpose registers in 16-bit register, this A register can be represented in the form of X. That means BX, CX, DX like this. Where X indicates, every case where X indicates 16 bits. These are the 8-bit registers A, B, C, D. The extension from 8-bit to 16-bit, X is the where X indicates 16-bit. Here AX, BX, CX, DX. The possibility is there. That means we are going to divide these registers into 2 categories, AL and AH, like this. This one, BL and PH, like this. It means lower base register, higher base register, lower accumulator, higher accumulator. In this case also same as it is. CX register can be divided into CL, CH. DX can be classified into DL, DH like this. Suppose if you want to consider 32-bit registers, the representation is like this. AX can be extended register, that means E AX, E, BX, E, CX, E, DX. E means extended of AX. AX is the 16. Extension means another 16. That means totally this is a 32 bit. If you want to consider 64 bit registers, the general representation RAX, RBX, RCX, RDX, where R indicates that means register extension. That means register extended AX, register extended BX, register extended CX, register extended DX, like this. Where R indicates 64-bit registers. All are rectangular boxes. If the register size is 8, inside 8 flip-flops are there. If the register size is 16, inside 16 flip-flops are there. If the register size is 32-bit, inside we are going to expecting 32 flip-flops. If it is a 64-bit register, we are going to expect 64 flip-flops are there inside of the register. Next one, special registers. Special registers are represented with, that means specially we are using, that means segment register, that means stack segment, code segment, data segment, next extra segment, like this R pointer, stack pointer, or base pointer, that means the index register, that means SI register, DI register, like this. Like this, we are going to classify it into two categories. The next point is, register is highest accessing speed. That means the accessing speed or the data providing speed is very high compared to remaining memories. Let us see here the small block. So which block indicates total computer memories. That means here registers is there. So here L1 cache, L2 cache. This is completely which represents cache memory. This cache memory is stored inside the CPU. That means inside the CPU, up to this memory also inside the computer. The registers are stored inside the processor. This processor inside the CPU, the complete whole memory is stored into the computer, inside computer. Flash memory, magnetic disk, optical disk, magnetic tapes, this is completely external memory or secondary memory or auxiliary memory. That means secondary memory, this is primary memory. Primary memory has some fixed length. There is no limit for secondary storage memories. We are going to see here different terms. First one is the speed. Speed of the register is very high compared to remaining memories. That means this is the increasing order. From bottom to top, the data providing to the processor is very fastest compared to remaining memories. And cost is also increases. Suppose if you want to observe from bottom to top, the cost and speed is also increases. That means, suppose if you want to executing any operation with the help of ALU, like this is the ALU. The help of ALU, we are going to generating some result. So for calculation purpose, you need to receive two register values like this. That means register 1 and register 2. With the help of this ALU, we are going to calculate that particular operation. Assigned operation will be performed by using ALU. R1 value is received like this, R2 value is received like this. After calculation, the generated result will transfer to the again register R3 like this. That means here for calculation purpose, you need to receive the direct values from the registers. That means the accessing data providing speed is very high compared to the remaining memories. Coming to this one, size of the register is very low or very small. The representation, this diagram which indicates the size. This magnetic tapes or optical disc size is very high compared to register. Register size is very low inside the computer, so that this is very little memory compared to the remaining memory sizes. The size is decreases, that means size is increases if you compare to the top to bottom like this. Coming to the access time. So access time means the above, that means this part is considered as the internal of the computer memories. That means this part we are going to consider the external of the computer memory, so that the accessing speed is also very high inside the computer. Accessing speed is very low. That means accessing time it will take very high compared to the inside computer memories, so that this access time is also increases if you consider from the next continuation basic term is bus. What is meant by bus? What is the need of bus inside the computer? So what will happen if you are using buses? What will happen? Here the first definition of the bus. Bus is defined as a group of wires. group of wires or group of conductors. Group of conductors. Suppose if you want to transfer data from module 1 to module 2, with the help of internal buses only, we are going to transfer some data in between two modules like this. If you want to transfer data from M1 to M2 or M2 to M1, with the help of this bus only, we are going to share some information. This bus is represented as a group of wires or group of conductors. For examples, in many block diagrams, this bus is represented like this. If it is /4, that indicates inside how many wires we are expecting. That means 4 wires we are expecting like this. Inside 4 wires we are expecting. So suppose if it is 8, the /8, that means this parallel bus is consist of 8 wires internally. So if it is represented 16, means 16 wires we are going to expecting inside this parallel bus. So coming to this one, the bus classifications. The bus can be classified into 3 categories. First one is data bus, and the second one is address bus. That means a data bus, address bus, and control bus. Control bus. Data bus is always represented in bidirectional representation, bidirectional bus. That means bidirectional conductor. Or here address bus always which represents unidirectional. Control bus always which represents in bidirectional also. Sometimes in many diagrams we are going to see this type of buses. The representation is like this. That indicates the difference in between these two. This is single bus bidirectional. This is a parallel bus bidirectional. That means this is a parallel bidirectional data bus. Here also same thing. But parallel means inside we are going to expecting many wires. Here parallel address bus, parallel unidirectional address bus. Same as it is here. Parallel bidirectional control bus like this. Unidirectional, this is a parallel bus. So combination of these three, we are going to calling another name. This is very, very important. Address plus data plus control bus, that is represented as a system bus. System bus. So the total buses is replaced by only one single bus. That is called as a, that means we are adding all these buses like this. That is called system bus. System bus can be represented as a address bus plus data bus plus control bus. What is the importance of this system bus? If you use this system bus, automatically you can avoid the complexity problem inside the motherboard. For example, these buses connections are represented like this. So CPU, memory, and input-output devices. With the help of this bus, that means control bus separate, address bus is separate, data bus is separate. So data bus is bidirectional to connection of the CPU and memory and input-output devices. Coming to this address bus also unidirectional like this, and the control bus is also bidirectional like this. Instead of these three, suppose if you are using only one bus like this, that is also parallel bus. The parallel bus which indicates address plus data plus control bus. So this bus can be represented, connection is like this. Connection representation is like this. With the help of, that means this diagram is enough for the only with single bus. So there is no need of this type of connections. So always if the interfacing or number of bus connections are reduces, automatically we are going to avoid the complexity problem. What is meant by complexity problem? The requirement of the hardware. If you decreases the requirement of the hardware, automatically the performance of the system will be increases. The last one, so let us see what is meant by address bus. Initially, address bus is bidirectional, which reads or which writes information into various sources. That means it reads the various sources, it reads the data from the various sources, or it writes the data into the various sources. That means like memory or register or IO devices. Same as it is here address bus. Address bus is always unidirectional and it is used to access the one location in the memory. That means, for example, if it is a memory, number of locations are there. Every location has some unique addresses there. So with the help of these addresses only, we are going to highlighting first this location. After highlighting or after pointing, after selecting only, then only we have to perform either read property or write property on this location. That means this address is you need to access initially. With the help of address bus only, we are going to pointing or we are going to selecting or we are going to accessing. So that always address is unidirectional means we are going to pointing one location in the memory, or we are going to pointing, or we are going to selecting one IO device in the external world. So like this, one more important was control bus. Control bus is actually it is unidirectional in some cases, but the representation always we are going to shown in bidirectional. Sometimes control unit will generate the control signals. The majority control signal, read and write control signals, which generates the control the entire environment of that motherboard. The control bus generates the control signal to control the entire operation inside the CPU. So not only these control signals, we are going to expect more number of control signals, means memory read, memory write, IO read, IO write, interrupt acknowledgement, interrupt instruction fetch. All those control signals are generated from the control unit and also bus controller device. This control unit will generate the control signal to control the entire environment of the motherboard.